Hello everyone, welcome to CFA Essentials. The topic today that I want to talk to you about is multiple regression. The topic of multiple regression will be on CFA level 2 and it's important to understand it, to know how to use it, also to evaluate if it is a good fit for your goals or the data that you have. As you can see on the screen that I created a table to compare between linear regression and multiple regression. I find it easier to learn if we can connect the new knowledge to the knowledge that we already have. So I assume that you learned the concept of linear regression at the CFA level 1, but if not, you can check out my other video up somewhere on the screen. So as you can see on the table, the linear regression is different from the multiple regression in terms of number of variables, the number of assumptions, and the number of parameters. Sounds interesting, right? And obvious as well. With the linear regressions, you just have only one dependent variables and one independent variables. But for multiple regression, you have one dependent variables, but you have two or more independent variables. The multiple regression also has more assumptions than the linear regression, and the difference is that the multiple regression, they have the assumptions of independence of independent variables because they have two or more independent variables, so they need to satisfy the condition of independent between different independent variables. And we will look into more details of the total 5 assumptions, and you can understand more about it. Multiple regression are used to explain relationships between financial variables, to test the existing theories, or to make the forecast. In this case, you build a model with the dependent variable is the stock return, and independent variables can be size, values, or profit margin, etc. So now let's go to the assumptions. And it's important for you to understand each individual assumptions, also how it affects the model if one of the assumptions is violated. Learning about the assumptions is very important. So the linearity is simple because this is a regression model. It still needs to satisfy the condition of linearity. The relationship between the dependent variables and independent variables is linear. The second assumption is homoscedasticity. And yeah, I don't blame you if you cannot remember this word, but basically it says that the variance for the regression residuals is the same for all observations, which also give us another concept is heteroscedasticity is a violation of that homoscedasticity. If it's violated, it causes an inflated t-statistic, and with an inflated t-statistic, it causes the model to be more fit than it actually is. So it's not a good model. It can be tested by the BP test or the robust standard test. The third assumption is the independent of errors, which state that the regression residuals are uncorrelated across the observation. If this assumption is violated, it causes serial correlation, and you can test it by using the DW test or BG test. And this one also caused the t-statistic to inflated and underestimate the standard error, which also caused the model to be seems better than it actually is. The fourth one is normality, and it states that the regression residuals is normally distributed. And it can be tested by the QQ plot, and if it's aligned along the diagonal, which means that it's normally distributed. And the last one is independent of independent variables, which if it is violated, is cause the problem of multicollinearity. If the independent variables are correlated or related to each other, you can correct it by reducing the variables. So when you, for example, reduce one independent variables, that independent variables will disappear. So the correlated or the connected between them disappear. Or another way that you can do is increasing the sample size. If you want to test it, you can test it by using the variance inflation factor. Of course, to be able to use the model, we need to evaluate how well that model explains the dependent variables. And to do that, we need to measure the goodness of fit. So there are 5 ways to evaluate it. First, we use the adjusted coefficient of determination, and it is taking into account the degree of freedom. Of course, the higher the better. Like the linear regression, when you use the coefficient of determination. The second way you can test the goodness of fit of the model is using AIC or BIC information. And it is opposite to the adjusted R square, which means the lower the number, the better. The other way is you can also test if the slope coefficient is significantly different from 0, which means that you will calculate the t statistic and then compare with the t critical. And if it is outside the bound of the t critical values, we can reject the null hypothesis, which means that it will be better fit. Or you can use the F statistic. This F statistic usually used to test the slope of coefficient to compare which one is a better fit. For example, one model you use 3 different independent variables, but the other model you use 5 different independent variables. And you want to know that which one is a better fit. So you use its F statistic to test if the slope coefficient of the omitted variables is significantly different from 0. If it is, which means that the 5 independent variables model is better explained the data than the 3 independent variables model. And the last one is log likelihood, and the higher the better. Besides using multiple regressions for the quantitative data, we also can use it for the qualitative data, which there's 2 different models that we can use. One is if the independent variables is qualitative variables, we call it dummy variables, and it can be used to test whether a specific condition applies. If the dependent variables is a qualitative variables, we can test if the data satisfy a condition or does not satisfy a particular condition. So that is the end of all the things that I want to talk to you about the multiple regressions. If you have any questions, please let me know in the comment down below. Thank you for watching, and I will see you in the next one. Good luck, and remember, 1,000 miles start with a single step.